Temperate woodlands and grassland are characteristic of middle latitude areas, where warm subtropical and cool subpolar air masses meet. This boundary is not fixed but moves north and south with the seasons and varies a great deal according to the geography and relief of the region. In the lower temperate latitudes, the western edges of the continents tend to have hot dry summers and mild, damp winter, while the eastern edges are warm and humid all the year round with frequent summer thunderstorms. In higher latitudes, the cool subpolar air masses are the more dominant influence, and the general eastward movement of the air brings rain to the western margins, giving damp, humid conditions in both summer and winter. The typical vegetation in humid areas is deciduous forest, but, in places where the rainfall is high and there is little difference between summer and winter temperatures, evergreen forests of both coniferous and broadleaf trees are found. Most of the tree species present are influenced by soil type and local relief. Pines are found on gravelly soils and rock outcrops, and alders and willows on waterlogged soil by rivers and streams, but the main types of tree are oak, ash, maple and beech. The characteristic feature of deciduous woodland is the difference between its summer and winter aspects. In the summer the leaves form an almost continuous canopy and little direct sunlight reaches the ground. After the annual shedding of leaves the trees stand stark and naked against the wintry skies, and the inhabitants are faced with new conditions of lightning and cover as well as of temperature and precipitation. They react to this in many ways, including hibernation and migration. The discarded leaf matter forms a thick, rich soil and contains three sources of plant nutrients: rotting plant material, humus and clay minerals. The humus slowly releases nutrients into the soil and also traps essential minerals, store potassium, sodium and calcium, important raw materials necessary for photosynthesis. In areas of seasonal rainfall where the total precipitation is between 25 and 75 centimeters, grass forms the dominant vegetation. Although all grassland areas have an annual period of drought lasting several weeks or months when the surface soil dries out completely, their fundamental characteristic is the total absence of moisture at depth in the soil. The lack of water at this level thus prevents trees, which have deep roots, from establishing themselves. The temperate woodlands and grasslands probably represent the habitats that suffered most during the age of man some 50 million years ago. Man cut down the forests to supply fuel and to provide space for agriculture and settlement. He plowed large tracts of grassland to plant cereals and created wide expanses of pasture land for grazing animals. These disturbed areas did not revert to their natural state until a long time after man's disappearance. This interference caused the extinction of a great number of animal genera native to the original habitats. However, some creatures did survive, and it was from these that the animals of today's temperate woodland areas are descended. The evolution of the major group of herbivorous animals during the period immediately before and during the age of man te principale large-scale grazers and browsers were the ungulates, the hoofed mammals. They were generally lightly built running animals, able to escape quickly from predators and with teeth particularly suited to cropping leaves and grasses. The ungulates were widely used by man for his own purposes. Cows and goats were domesticated for milk and meat, sheep were bred for wool, and the skins of many were used for leather. Horse and oxen were harnessed to work for man and became the classic beasts of burden. By the time man became extinct, these animals had become so dependent to him that they could no longer survive. The deer, the wild ungulates of the temperate latitudes, fared little better. Vast tracts of temperate woodlands had been destroyed to make room for man's cities and to provide agricultural land. This interference with their habitat was so intolerable and put such pressure on the deer that their numbers fell to a level from which they never recovered. What then could take their place? A whole ecological niche was vacant with nothing to exploit it. Which creature was best placed to take the initiative? During the age of man, a small-scale grazer was present that was so successful it was considered to be a pest. The rabbit was so seriously destructive of man's crops, that man made numerous attempts to control it and even attempted to exterminate it. Yet no matter what actions he took, he never succeeded in getting rid of it completely. After man's disappearance, the rabbit's versatility and short breeding cycle enabled it to develop successfully into a number of separate forms. The most successful, the rabbit, now occupies the niche left by the ungulates. To begin with, the rabbit changed little from its rabbit ancestors excepting for size. In an environment totally devoid of large, hoofed grazing animals, the rabbit was left with no major grazing competitors and quickly evolved to occupy the position they once held. The early rabbits retained the hopping gait of their forebears and developed strong hind legs for leaping. However, although jumping was ideal for moving around the open grasslands, their traditional habitat, it was not the best method for the confined spaces of the forest, and a more fundamental change had to take place. Several species of this earlier line still exist, but their place has largely been taken by the running forms of rabbit that more closely resemble the deer of earlier times. The second major development took place some 10 million years after the Age of Man. As well as developing rapidly into the size of a deer, the rabbits also began to evolve the typical deer leg and gait. The jumping hind limbs and the generalized forelimbs of the rabbit grew into long-shanked running legs, and the feet changed radically. The outer digits atrophied and the second and third toes grew into hoofs, strong enough to this line has now largely replaced the leaping form as the dominant group. The rabbit has been so successful that it is found in a wide variety of forms throughout the world, from the tundra and coniferous forests of the far north to the deserts and rain forests of the tropics. Forest-dwelling rabbit of temperate latitudes is the archipel species of the genus Ungulagus. It grows to around 2 meters high and has a dappled coat which camouflages it effectively among the trees. They are normally found in small herds of between 10 and 12 individuals. Ungulagus scandens, mountain rabbit. This is the smallest and the least common of all rabbit species and is found along the western mountains of the northern continent. It is adapted to live on a meager diet of poor grasses and herbs. Ungulagus flavus, desert rabbit, a much more lightly built creature with long ears and a short sandy-colored coat. The desert shoulder stands no more than 1-2 meters high at the shoulder and is found in arid areas throughout the world to the south of the temperate belt. The Arctic rabbit has a thick hairy coat which turns white in the winter. Heavily built with rolls of insulating fat, it is found in the far north, in the region of the tundra and coniferous forest. In the mammal world, the predators were traditionally carnivores, specialized meat-eating animals with teeth modified for stabbing, killing and eating flesh. Their legs were designed for leaping and producing a turn of speed that could quickly bring their chosen prey within killing distance. Wolves, lions, saber-toothed, stoats, these were the creatures that fed on the docile herbivores and kept their numbers in check both during and before the Age of Man. However, being very specialized, these species tended not to have a great lifespan. They were so sensitive to changes in the nature and the populations of their prey that the average life of a carnivore genus was only 6.5 million years. They reached their acme just before the Age of Man, but have since decreased in importance and are now almost extinct except for a number of aberrant and specialized forms found in the coniferous forest of the far north and in the South American island continent. The place of the carnivores, as the principal mammal predators, is now occupied by a variety of mammal groups in different parts of the world. In temperate regions, the descendants of the rodents occupy this niche. When the carnivores were at their peak, the rodents, particularly the rats, began to acquire a taste for meat and animal waste. The spread of man to all parts of the world encouraged their proliferation, and after man's demise they continued to flourish in the refuse created by the disruption and decay of human civilization. It is this adaptability that has ensured their survival. Despite the specialized nature of their teeth, rats were able to live on a wide range of foods. At the front of their mouths they had 2 sharp gnawing incisors, which continued to grow throughout life to compensate for wear and which were separated by a gap from the back teeth. These were equipped with flat surfaces for grinding vegetable matter. This is very different from the typical carnivore dentition, which had cutting incisors at the front followed by a pair of stabbing canines and a row of shearing teeth. As the rats expanded to occupy the niches left by the dwindling carnivores, their teeth evolved to fulfill their new role. The gnawing incisors developed long, stabbing points and were equipped with blades that could cut into and grip their prey. The gap between the incisors and the back teeth became smaller and the grinding molars became shearing teeth that worked with a scissor action. This dentition was crucial in the development of the predator rats and allowed them to radiate into the numerous forms and varieties seen throughout the world today. In temperate latitudes, the larger herbivores, the grazers and browsers of the plains and forests that were one time prey to the wolf, have now become the prey of the phalanx, a very large dog-like rat which hunts in packs. The evolution of this form involved the modification of the limbs from the fairly generalized scampering legs of the rat to very sophisticated running organs with small, thickly padded feet, and long shanks powered by strong muscles and tendons. It's the commonest species of predator rat found in the temperate latitudes. The Rapide Amphimorphodus longippus, a native of the northern plains, is built for speed. Its highly flexible spine gives it the added impetus to reach speeds of over 100 km per hour. The janicet is a long-bodied, burrowing predator, strongly resembling the extinct stoats and weasels, and like them will swim, climb trees and turtle underground in the pursuit of its prey. The ravine is about the size of the extinct fowl or wild cat and preys on small mammals and birds. It has long claws and pointed stabbing fangs. Life beneath the trees of the broad-leaved forests. The undergrowth of a temperate wood, the humus and leaf litter and added to annually by the autumnal shedding of deciduous leaves, provides a rich source of nourishment and shelter for all sorts of animals. The primary consumers of this material are bacteria and invertebrates, such as worms and slugs, which in turn provide food for many mammals and birds. The insectivores are therefore well represented in this habitat, not only in their primitive role of small insect eater but also in a number of varieties that have adopted a predatory, carnivorous mode of life. Tested on as a descendant of the primitive hedgehog, the spines of its ancestor have been replaced by a series of hinged, armored plates which can be drawn together into an impregnable sphere when the animal is threatened. When rolled up tightly it is almost impossible to grip or penetrate, and even the most determined predator rat finds a meal from this little animal more trouble than it is worth. The tusked mole comes somewhere between the old order of insectivorous animals and the newer carnivorous ones. Looking very much like a mole of 50 million years ago, it leads a burrowing existence and has adopted the streamlined shape, velvety fur and spade-like feet of its distant cousin. However, here any resemblance stops. It has two tusks extending from its jaws, and a paddle-shaped tail. As it burrows, the animal pushes forward with its feet in a rolling motion so that its tusks ream out the soil in front of it. The loose soil is pushed back by the feet and compacted to the tunnel walls by its tail. As well as eating worms and burrowing invertebrates, it also preys on small surface-living animals, especially mice, voles and lizards. The tusked mole lies in wait just below the soil surface, listening for sounds of movement above. When it hears its prey approaching, it springs out, using its tail as a lever, grasping the creature with its teeth. The most interesting example of a previously insectivorous creature turned meat-eater is the oakleaf toad. It gets its name from a peculiar fleshy outgrowth on its back that looks exactly like a fallen oak leaf. The toad lies partly buried in the leaf litter, totally camouflaged and quite motionless except for its round, pink tongue which protrudes and wriggles about just like an earthworm. Any small animal that approaches to investigate falls victim to the toad's powerful jaws. Mammals and birds of the tree tops. Plant-eating mammals abound in the trees of the deciduous forests, eating shoots and leaf buds in the spring and fruits and nuts in the autumn. The long-bodied squirrel, known as the chiriton, is a typical plant-eating mama. Its peculiar shape is a legacy from an immediate ancestor, the tree-burrowing rodent of the northern coniferous forests. As it spread south into the temperature woodlands, it found that it no longer needed to make deep tunnels in the trees to escape the harsh winter, and as a result the animal's specialized chiseling and gnawing teeth became smaller, its dentition reverting to be more like that of its distant ancestor the gray squirrel. Its bodily shape, however, was still perfectly adapted to life in the trees and remained unchanged. Now that the animal no longer led a burrowing existence, its legs and feet had to evolve to suit its new environment. Its hind feet, although small and short, became very powerful and developed strong, gripping claws. The underside of its short tail grew hard and scaly, and with its hind feet formed a strong three-point anchor that could secure the animal to the tree while it reached out to collect food. As its squirrel ancestor's jumping ability has completely disappeared, the animal can only move from one tree to another by reaching out and grasping an extended branch. For this reason the chirit is found most often in dense thickets, where the trees are close together. Its only enemies are birds of prey. ANCI is really only vulnerable to these when feeding in the topmost branches. It retains the predilection of the burrowing squirrel for excavated by wood-boring birds. Wood boring is the speciality of a group of insectivores known as tree drummers. These animals, basically shrew-like in form, subsist on a diet of grubs and insects, which they gouge out from crevices in the bark. They have masses of sensory bristles on their feet and very large ears, which help them to detect the movement of grubs burrowing in the wood. When a tree drummer finds a grub, it drives its chisel-like teeth into the bark to make a hole big enough to enable it to remove the grub with its trunk like proboscis. Sometimes the grub becomes skewered on its chisel teeth and needs to be carefully plucked off before being eaten. It is really the birds that are the masters of the trees. After the great reptiles became extinct, over 100 million years ago, the birds expanded into an enormous number of species. Being primarily designed for flying, birds had access to the tree tops in a way that few other animals had, and finding that they were safer there than on the ground, they soon became perfectly adapted to this new habitat. As a result, many woodland birds have developed feet with curved opposable toes that are ideal for gripping branches. In one species, the tree goose or hanging bird, these toes have been reduced to 2. They are permanently curved and enable the bird to hang upside down without effort. Because of the bird's size and weight, this attitude is much easier to maintain over long periods than an upright stance, and it has taken to spending long periods roosting in this position. The night life of the temperate forest. As night falls in the temperate woodland, the sleeping animals of the day are replaced by a completely new set of creatures. Nocturnal birds, bats and insects, a whole array of creatures is found that are as diverse and numerous as those of the daytime. As dusk falls and the moths and night-active flies take to the air, the insectivorous bats appear to feed on them. Bats have proved so successful in their shape and life that in most parts of the world they have remained remarkably stable in shape and form ever since they first appeared over 100 million years ago. Save for the development of a more sophisticated echolocation system, positioned at the front of the face, and the absence of eyes, little else has changed. The purrup bat, so called because of its curious voice, is found through temperate latitudes. Unlike the earlier bats which generally navigated using high-pitched sounds, the purrup bat uses a much wider range of frequencies extending well into the audible level, giving it a much more sophisticated picture of the terrain. Its sensitive ears are positioned far forward at the front of its face to provide it with the largest possible sound-collecting surface. The ludes, a descendant of the rabbit, live in direct competition with the ancient groups of small rodents, the mice and voles. In some areas the ludes have replaced the rodents completely, whereas in other parts of the woodlands, where the conditions particularly favor them, the rodents have remained successful. The ludes resemble the small rodents in many respects, particularly in size, but their rabbit ancestry is obviously displayed in the shape of the head and tail. They feed mostly at night, nesting during the day in crevices among tree roots or in holes in the ground. Its large rabbit-like ears betray its ancestry. Another small animal that provides food for birds of prey is the trutiel, an insectivorous related to the chisel-toothed shrews of the trees. The incisors of both the upper and lower jaws of this animal are extended forward to form a structure like a bird's bill, which acts as a probe to catch worms and burrowing insects in soft earth and leaf litter. The trutiel is completely blind and retains no vestiges of eyes. It is, however, equipped with a large number of sensory whiskers and extremely acute hearing. Its ears, which are enormous for the size of its body, can be rolled into trumpets by a unique set of muscles located at their base and then pressed to the ground to listen for sounds of burrowing. It uses its long beak to probe deep into the earth for worms and grubs. The shrok is a much larger animal. Descended from insectivore stock, it has a size and shape comparable to that of the extinct badger. It makes nightly forays through the undergrowth and will take any prey that it chances upon. It has a long snout and broad forepaws with which it digs after burrowing animals and excavates its own family nest in soft soil under tree roots. The shrok's outward similarity to the badger is an excellent example of convergent evolution. Life in the fens and marshes. In temperate latitudes, wetland areas are comparatively isolated pockets of land found scattered widely across the northern continent. As well as strictly water habitats such as ponds, lakes and rivers, they also include stretches of salt marsh and fenland found near the sea, mires and peat bogs found in poorly drained inland regions and areas of regular inundation. The conditions found throughout this range of habitats is so diverse in terms of salinity, oxygenation, light penetration and water currents that vary. Nearly every individual location has its own little ecosystem and associated fauna, and almost every animal group is represented. A mammal frequently found near river banks and lakesides is the reedstilt. Its long, slender legs and neck and vertical stripes render it almost totally invisible among reeds, where it is frequently found fishing. Its head and neck are most unusual. Practically all mammals have 7 neck vertebrae, not the reedstilt has 15. In evolutionary terms, the extra vertebrae have appeared quite recently and result from the fact that, in fishing, longer-necked individuals have an advantage over the others. The tooth pattern is degenerate, the incisors, canines and molars having all reverted to an almost reptilian condition in which they are all of the same shape. The reedstilt uses this combination of neck and tooth features to catch fish by darting out its long neck and snapping shut its needle-pointed teeth. It stands motionless in the water until a fish swims directly beneath it. Plunging its head into the water, it seizes the fish, straightens its neck and swallows it. The lower parts of its legs are covered with hair and probably provide camouflage as well as protection. On its thin legs, the reedstilt stands nearly a meter high at the shoulder. One of the most unusual water-living mammals is the Temperate, a tiny insectivore descended from the primitive shrews. Its length, excluding its tail, is less than 5 centimeters, which puts it among the smallest mammals in existence. Although its body is thin, its feet and tail are broad and are covered with water-repellent hairs, which spread its weight over such a large area that it can skate across the water without breaking the surface tension. It lives mainly on the larvae of mosquitoes and midges that are found just under the water surface. It feeds on them by piercing their outer cuticles with its long, hairless snout and draining them of their vital juices while they are still in the water. In this way the Temperate avoids disturbing the water surface, which would both upset the surface tension and frighten away its prey. Its mouth extends forward into a long, tubular snout, which carries a set of fine teeth at the tips capable of piercing the outer skin of an insect larva. The coniferous forests of the northern continent represent the greatest expanse of uninterrupted forest in the world. Coniferous trees do well at high latitudes because they are evergreen, and photosynthesis can take place immediately conditions are right for growth without having first to produce leaves, as is the case with deciduous trees. In this way the conifers compensate for the short growing season, which is about 50 to 80 days depending on the latitude. Fruiting and reproduction are also in tune with the climate. Conifers, unlike deciduous trees, do not produce fruiting bodies that are pollinated and ripen within a single year. The fertilization of a female cone may take more than a year to complete, and as many as 3 more years may elapse before the cone matures and the seeds are ripe for dispersal. The lack of leaf litter and the prevailing cold conditions which inhibit the natural decay of the forest's pine needle carpet, material that is slow to decompose in any case, results in only a thin underlying layer of topsoil and little or no undergrowth. The indigenous mammals are largely herbivorous and exist mainly on diets comprising mosses, pine needles, bark and seed cones. Insectivorous birds are rare compared with those that feed on cone seeds and buds. Throughout the region forest fires are not uncommon, usually occurring in spring, when the trees are low in sap. Large areas can be devastated at a time. Recolonization is firstly by deciduous trees such as birches, alders and rowans that are only later replaced by the climatic vegetation of spruce, larch, cedar or pine. The coniferous tree's typical tall, pointed shape is ideal for bearing the weight of the winter snowfall and allows the snow to be shed quickly when it melts in spring. Their surface-spreading root systems are perfectly adapted to the shallow soils that are characteristic of the habitat. In the north of the region, where the underlying soil is frozen all year and is therefore impervious to water, there are many lakes, streams and bogs with their own localized flora and mosses and sedges. The forest is more open and blends into the neighboring tundra. Larger patches of tundra mosses and lichens appear on high and extends far northwards along sheltered valleys into the tundra. At the southern edge of the coniferous belt, the conifers grade imperceptibly into deciduous woodland. Throughout the world, smaller areas of coniferous forest are found outside their normal latitudinal extent, particularly on the slopes of mountains, where the latitude produces climatic conditions similar to those experienced near the poles. During the age of man the coniferous forests experienced considerable environmental damage, due mainly to clearance for agriculture and also in the course of commercial forestry. This effectively exposed large areas of land to the erosional effects of wind and rain, destroying the soil structure and consequently reducing its water retention capacity. The coniferous forests took some time to recover from this damage, for the normal successive recolonization could not take place immediately. The evolution of the hornheads. The browsers are the largest animals living in the coniferous forest regions. They feed mainly on young twigs and needles in the summer and subsist on bark, mosses and lichens during the rest of the year. Soon after their arrival in the coniferous forest, the ancestral hornheads' jaws and horns began to evolve in response to their new environment. In common with all the now almost extinct ruminants, most of these creatures possessed no upper incisor teeth. They cropped grass by working their lower incisors against a bony pad on the roof of the mouth. However, this system is not particularly effective for browsing from forest trees. The first change that took place was the horny head plate became muscular and grew forward to form a sort of beak. The lower lip became muscular and grew forward to meet it, thus extending the mouth some distance beyond the front teeth. This fairly primitive arrangement is still found in several species, for example helmeted hornhead. In more advanced forms, however, the lower jaw is also extended so that the lower front teeth meet the horny beak instead. These adaptations are the result of evolutionary pressure that enabled only those forms that could feed successfully on the twigs, bark and lichens of the coniferous trees to survive. The elaborate horn formation above the eyes is also used as defense. The later hornheads, such as the common hornhead, have longer lower jaws and bite by bringing the lower incisor teeth into contact with the upper horn lips. Hornheads stand about 3 meters high at shoulder. Their horns, originally developed for a defensive role, have evolved since as browsing tools. They also play an important part both in courtship and in male dominance struggles. The bone structure has been carried one stage further in the water hornhead, that inhabits lakesides and the banks of rivers. In this creature the horny plate extends forward into a broad rake-like structure, with which the animal grazes on soft water weeds that it finds on the beds of ponds and streams. It had 2 broad hooves on each foot, set widely apart and connected by a web of skin, which prevents the animal from sinking into soft mud and sand. The water hornhead, in its way of life, must surely resemble the hadrosaurs. The relationship between predator and prey. As in all others habitats, the animals of the coniferous forest fall into the familiar food chain pattern of predator and prey, with the carnivorous animals forming the final link. Here, as in the temperate woodlands, the fiercest and commonest hunters are the predator rats. They hunt beneath the trees in small packs, tracking down the rabbit and the hornhead, singling out the weak and elderly individuals and running them to exhaustion. The predator rats take it in turn to attack, savaging their prey with powerful front teeth. Hornheads have such powerful horns that, when they are the quarry, it is almost as dangerous for the hunter as it is for the hunted. A predator unique to the coniferous forest is the Temperate, a large weasel-like creature and one of the few true carnivores still in existence. Its size, up to 2 meters in length, makes it by far the largest predatory animal found in the region, and it probably owes its survival to its low, powerful build and its ability to run through the sparse undergrowth easily, bursting out suddenly upon its prey. Temperate live in small family groups and normally hunt in pairs. Not all the predators are mammals, birds also kill their share of the small animal population. The broadbeak, one of the larger birds of prey, has a wingspan of over a meter and lives in the western forests of the northern continent. It is descended from the starlings, which expanded to fill the gap left when many of the ancient predatory birds became extinct during the Age of Man. It has a rounded tail and broad, blunt wings, which enable it to fly swiftly and maneuver in the tight spaces between the trees. It has a straight, powerful bill and strong talons, which it uses to grip its prey. With so many predators in the coniferous forest, it is not surprising that the smaller mammals should have evolved such a variety of defensive ploys to ensure their survival. The spin-tailed squirrel is an excellent example of their ingenuity. It has a long, broad, flat tail with quills developed on its underside, which when at rest lie flat over the ground. However, when the animal is alarmed it throws its tail over its back and the sudden increase in skin tension erects the quills. This presents an almost impenetrable barrier and can be turned to deflect an attack from either side. One large rodent that became adapted to a semi-aquatic way of life during the Age of Mammals, partly as a defense against predators, was the beaver. After man, the beaver became even better adapted to life in water. Its tail and hind feet have become fused together into one large paddle, which, when powered by its backbone, produces a powerful up and down swimming stroke. Its ears, eyes and nose are placed high up on its head and remain above water when the rest of the animal is submerged. Surprisingly, the paddle does not impair the creature's movement on land and is used as a grasping limb, enabling it to climb partway up trees, increasing its potential supply of food and building materials. Birds and mammals that feed on and in the trees of the coniferous forests. Throughout the age of mammals, the rodents were once of the most successful animal groups in the coniferous forests. Their powerful teeth enabled them to cope with the tough vegetable matter found there, and their warm, furry coats helped them to retain body heat during hibernation. The chiselhead, a rodent and a relation or the temperate woodland chirrits, is highly adapted to life in the coniferous forest. Its huge incisor teeth and worm-like body enable it to burrow deep into the living wood, where it can remain protected from the cold in winter. Although in some ways the animal is at an advanced stage of development, its parasitic way of life is really quite primitive. Its staple diet is the bark of trees, which it strips off completely, leaving the tree totally denuded. This, combined with the massive damage it does by burrowing, kills the tree within a few years. As the chiselhead only colonize live trees, they must be continually on the move, and every spring, after hibernation, the young of the new generation migrate to find new territories. During migration they are very vulnerable and many are taken by predators before they can complete the journey. The balance between burrower and predator is highly critical, and it needs only a slight reduction in the number of predators to produce an increase in the population of burrowers that would lead to the total destruction of vast areas of coniferous forest. No other small rodent found in the coniferous forest is quite so destructive. Most live on shoots, bark and the seeds found in cones. Many are ground dwellers and feed from the cones where they fall. Others are lightly built and agile enough to scramble along the branches to where the cones are actually growing. One large vole-like rodent, the trevel, is unusual in having a prehensile tail. Too heavy to reach the cones growing on the slenderest branches, it feeds on them instead by hanging by its tail from a sturdy neighboring branch and reaching out with its front paws. Like other rodents of this general size, it gathers more than is necessary for its immediate needs and stores the rest for the lean winter months. Its hibernation nest is a long, drooping structure woven together from grass, strips of bark and pine needles. Built hanging from the end of a branch, it is large enough to accommodate the animal together with sufficient food to see it through the winter. Of the many seed-eating birds found in the coniferous forest, the largest by far is the common pine chuck. The two sexes of this species are quite different, both in appearance and in their mode of life. The male is much more powerfully built and is equipped with a massive beak, which it uses for breaking open pine cones to feed on the seeds. The female, much smaller and drabber, totally lacks the male's heavy beak and is really a scavenger, supplementing her diet with carrion, insects, grubs and birds. Appearance to the present-day female and the male has evolved its own distinctive features primarily for display, and its eating habits are a secondary development. The male uses its heavy beak like a nutcracker to crush pine cones. The sexes of the common pine chuck are so different in appearance that they look like different species. The bleakest places on the surface of the Earth are found around the North and South Poles, regions of constant ice and snow where no plants grow. Because of the tilt of the Earth, at certain times of the year no sunlight whatsoever reaches the regions and night lasts for months at a time. Even during summer, when daylight is continuous, the sun's rays hit the ground at such a shallow angle that very little warmth is felt. These conditions prevail both on the southern continent of Antarctica and on the ice mass that covers the northern polar ocean. The extent of the ice on the polar ocean is dependent on the low salinity of the Arctic waters. A saltier sea would not freeze over to such a degree. The polar ocean is separated from Atlantic Ocean by a barrier of islands that inhibits their intercirculation. This island chain is formed from what was once a single island known as Iceland. It consisted of lavas that erupted from the mid-Atlantic ridge as the crustal plates of Europe and North America moved away from one another. As this movement continued, enlarging the Atlantic Ocean, Iceland, straddling the mid-oceanic ridge, split into two parts, each moving in opposite directions. The continuing volcanic activity spawned a string of new islands in the growing gap between the two parts. Almost 180 degrees away, at the opposite side of the Arctic Ocean, the same crustal movements were responsible for closing the Bering Strait, the gap between North America and Asia, and fusing the two areas into one vast northern continent. As a result, the polar ocean is now practically landlocked, and is fed by the rivers of the surrounding supercontinent. The generally low-lying areas fringing the polar ice sheets comprise the tundra. During winter they are as cold and bleak as the Arctic wastes, but in summer the temperature rises above freezing and may reach an average daily temperature of 10 degrees Celsius. In summer the snow melts, but because of the permafrost, the layer of perpetually frozen soil beneath the surface, the water cannot drain away and floods the numerous hollows and depressions. Spring on the tundra is a time of spectacular change. A sudden bloom of vegetation bursts forth to take advantage of the brief growing season. Much of the vegetation reproduces asexually rather than by producing seeds, as is the case in warmer regions. Vegetative reproduction is much faster and therefore, because of the short summers, much more successful. Those plants that do reproduce sexually produce seeds that are highly resistant to frost. Mosses, lichens and low bushy herbs are typical of tundra plants. The tundra vegetation's sudden summer flourish is accompanied by a bloom of insects, and in spring a veritable plague of flying creatures emerges to take advantage of the short period of warmth and sunlight. The seasonality of plant and insect life on the tundra means that for most mammals and birds food is only available during part of the year, and most of the larger animals are consequently migrant, spending the harsh winters to the south. In the southern hemisphere there are no equivalent large landmasses at latitudes that would produce a covering of tundra vegetation. The tundra that exists is found scattered on the islands of the Southern Ocean and on mountains just below the snow line. The wandering herds and their predators. In comparison with other parts of the world, the animal and plant life of the tundra consists of a rather small number of species, each of which contains a relatively large number of individuals, a situation which is diametrically opposite to that found in the tropics. The low species count is entirely due to the region's inhospitable conditions. All tundra animals have evolved from creatures found in more temperate areas. Their ancestors probably colonized the tundra only because they were driven to do so by fierce territorial competition. Life has to be unusually unpleasant elsewhere for a group of animals to venture into the tundra in the first place. For many large animals the tundra is only habitable during the summer months, and in winter they migrate southwards into the coniferous forests, where conditions are less austere. The largest of these animals is the woolly gigantelope, a close relation of the tropical gigantelope. It differs mainly in size and in the possession of a large, fatty hump, which provides it with nourishment during the hungry winter months. It has a long, shaggy winter coat and broad hooves, which prevent it from sinking into soft snow. It uses its enormous horns as snow plows to expose the mosses, lichens and herbaceous plants on which it feeds. Its eyes are small to avoid being frost-bitten, and its nostrils are bordered by blood vessels that warm the air before it reaches the lungs. In early summer, the woolly gigantelope loses its shaggy coat and takes on a much sleeker appearance. The hump which sustained it through the winter months is now entirely depleted, and it spends much of the time eating to rebuild its energy store for the long trek back south in the autumn. The bartolo is a creature that would have been very much at home back in the first half of the age of mammals. At that time elephants, animals of comparable size to the gigantelopes, were preyed on by saber-tooths. These creatures, members of the cat family, had long, stabbing canine teeth with which they inflicted deep, stabbing wounds on their quarry. After an attack the saber-tooths would wait until the elephants bled to death before moving in to feed. This successful arrangement was even evolved independently among the marsupials. However, during the age of man the elephants declined, and the saber-tooths, being entirely dependent on them, died out completely. With the advent of the gigantelope the saber-tooth pattern reappeared, but this time among the predator rats. The bartolo, unlike other members of the group, exhibits sexual dimorphism in that only the female is equipped with saber teeth and hunts the gigantelopes. The male, having none, resembles more the polar bears that once inhabited these latitudes. A compact ecosystem. As the constantly frozen ground of the tundra makes digging through the earth impossible, all small burrowing rodents found in the tundra are snow tunnelers. One tunneler in particular, the meeching, similar to the ancient lemming from which it may be descended, has a very considerable effect on the evology of the area. A colony of meechings may be started by as few as 3 or 4 individuals. They breed profusely, and as their numbers grow they build a fortress of matted vegetable material to protect them from the frosts and snows. The interior of the fortress is very complex and consists of a network of passages and tiny chambers, one for each individual. During the winter each rodent is fully insulated and kept warm while the rest of the colony. The meeching's fortress is built of vegetable matter, principally mosses and lichens. The interior is divided into chambers, one for each adult. Initially a 4 or 5 chambered nest, the meeching's fortress grows exponentially, reaching its maximum size after about 5 years. One of the largest bird is the booty bird, a descendant of the crow. It has a long neck and bill and long legs, and in this respect looks rather like a heron. Indeed, in summer it even behaves like a heron, wading into shallow pools and streams to dip for fish. In the winter it develops insulating feathers along its legs to protect them from the cold and becomes a land predator, hunting any small animals that are active at the time. Booty bird stands over a meter high, and it is so called because of the shaggy feathers it grows to protect its legs in winter. The gandamoth is descended from the magpie. It means much of its original body shape and coloration, but has a hooked beak and pointed wings like a skua. In summer it feeds on rodents and small birds in the tundra, but spends the winters in the coniferous forests to the south as a scavenger. Its survival in the cold north due in no small part to the fact that it is a brood parasite, laying its egg in the nests of other birds to be incubated and hatched by them. In this way it conserves the energy it would otherwise use in nest building and brood rearing, at the expense, however, of the ducks and waders on whose nests the eggs are laid. Life in the Northern Sea. The Northern Sea is almost landlocked and contains a permanent ice cap, which has a considerable influence on the environment of the surrounding continent and contributes substantially to the stability of the region's cold climate. The ice cap is maintained only because the polar ocean is fed by enormous quantities of fresh water by the rivers of the surrounding continent. This gives the sea an unusually low salinity and therefore a strong tendency to freeze over. In winter the polar ocean is largely barren. In spring, however, the sunlight produces a bloom of unicellular algae near the surface, which provides food for the microscopic animal life that forms the basis of the oceanic food chain. In spring, shoals of pelagic fish come northwards through the northern island barrier to feed on the zooplankton, bringing with them countless numbers of seabirds. The first species to arrive is the flightless auk, a totally aquatic creature with paddle-like wings. In this respect they resemble the penguins, which were so successful in the southern oceans in earlier times. Except during winter the flightless auks rarely come ashore or climb onto the ice, where they are quite defenseless. They retain their EGSG until they are almost ready to hatch and lay them in the open water. The flightless auks exist as a chain of subspecies around the polar ocean capable of breeding with their neighbours excepting at the ends of the chain, where differences in size and physiology make it possible. Preying on the fish, are the pytherons, a group of aquatic carnivorous mammals related to predator rats. It reaches a length of about 4 meters and has an insulating coat of matted hair made up of a mosaic of solid plates, giving it a lumpy rather than streamlined appearance. The pytheron, although totally unrelated, has an appearance similar to the ancient seals and sea lions. Spread-eagled on an ice floe it appears lumpish and ungainly. In the water it is swift and graceful, swimming like a penguin. Among the organic detritus on shallower areas of the ocean bed are found banks of shellfish. Living on these shellfish is the Distarterops, by far the most massive aquatic relative of the predator rats. It reaches a length of about 4 meters and has an insulating coat of matted hair made up of a mosaic of solid plates, giving it a lumpy rather than streamlined appearance. Its most unusual feature is its teeth, the upper incisors from long, pointed tusks. The left hand one projects forward, whereas the right hand one points straight down and is used as a pick for removing shells from the sea bottom. This asymmetry is also found in the limbs. The left foreflipper only is equipped with a strong claw, which it uses to dislodge particularly stubborn shells. Because the Distarterops evolutionary line separated from the predator rats when they were both still comparatively small rodent-like creatures, it would appear therefore that the predator rat's double-pointed incisor teeth, from which the Distarterops tusks have evolved, were a comparatively early development. Distarterops are gregarious creatures and are often found resting on ice floes during the summer months in small groups containing both males and females. The female's tusks both curve downwards, whereas the male's tusks point in different directions. In all cases the male's forward-pointing tusk is formed by the left-hand upper incisor, and similarity only its left-hand flipper is endowed with a claw. The origins and ancestry of the vortex. In contrast with the vast southern continent, which supports life only around the edges, the surrounding ocean teems with life. Among its most notable inhabitants is the vortex, the largest animal found anywhere in the world. Resembling many of the sea creatures of the past, it has a long, tapering, necklace body, a powerful paddle-shaped tail and long stabilizing fins, an ideal arrangement for efficient movement through water. Similar shapes can be seen in the great arthrodires of the Age of Fishes, in the pliosaurs of the Age of Reptiles, and in the whales of the first half of the Age of Mammals, the last creatures to occupy this ecological niche before the vortex. The vortex is in fact descended from the penguins, which, although they were birds, had long since lost the power of flight and were totally adapted to an aquatic life, excepting for one thing: they always had to come on shore to lay eggs. This remained so until, shortly after the extinction of the whales, one species of penguin developed the ability to retain its single egg internally until it was ready to hatch and gave birth to live young in the open ocean. Freed of the necessity to come ashore, this species became completely marine and ultimately gave rise to a completely new order of marine birds, the pelagornids. The vortex is a plankton eater. Its beak has developed into a large plankton sieve, which consists of a very fine mesh of bone plates instead of celeste hair, as the case of the whale's baleen plates. At over 12 meters long, it is the largest creature on Earth. The pelagornids are unique in the aquatic world in that, like their ancestors, they are both warm-blooded and egglayers, albeit that their eggs are retained within the body until the moment of hatching. In this respect they resemble the mammals and some reptiles. However, it is important to note that pelagornids do not possess mammary glands with which to feed their young, as do mammals, and are warm-blooded as reptiles are not. The porpoise, like most of its class, is a fish eater. Its distinguishing feature is a long, serrated beak that enables it to catch larger fish than would otherwise be possible. So successful has it been that it has remained virtually unchanged for the last 40 million years. Around the volcanic islands of the Southern Ocean are found the skern, a species of flightless seabirds that have evolved a unique behavioral quirk in response to the problem of incubating eggs in this hostile environment. As well as being a hazardous time for the embryo chicks, the parent birds also run the risk of exposure. The skern has solved the problem by laying its eggs in the warm volcanic sands of the islands and deserting them immediately afterwards. It is able to delay the time of laying until the temperature of the sand is exactly right. When a volcano shows signs of acticity, it immediately becomes the scene of frenzied activity. The birds scramble ashore, and with the aid of their temperature-sensitive beaks probe the sand for areas with the right condition for incubation. After laying their eggs 10 to 20 centimeters deep and covering them with sand, they return to the sea, seeing neither their eggs nor their offspring again. Skerns are found mainly around the volcanic islands of the Southern Ocean. They have oily green plumage, large feet and legs, but no wings. They cannot walk but use their legs to push themselves along on their bellies. Swimming at the surface, they sit very low in the water. When hunting fish underwater, they become graceful and agile swimmers. The effect of altitude on animal communities. The flora of the mountains has much in common with that of tundra regions because of the similarity in climatic conditions found here: low temperature, high precipitation and short growing season in both habitats. Although the mountain areas of the world are so isolated and widely distributed that they can largely be regarded as separate faunal provinces, the fauna of the fold mountain belt between Africa and Europe show characteristics that are typical of mountain life the world over. The ruffle, a descendant of the rabbit, exhibits many of these features. It has a rounded head and body, and disc-like ears, adaptations that guard it against cold. It has long hair under the neck and body to protect its legs from the cold, and its teeth are well adapted for grazing mosses and lichens. The upper incisors are set at an angle and are used for scraping the patchy vegetation from the surfaces of rocks and boulders. The ruffle's front teeth are designed for eating mosses and lichens. Shaggy hair on the undersides of its legs and on its feet give it a booted appearance. It is sure-footed over boulder and loose scree. The growth, a variety of small hornhead frequently found grazing on grassy, south-facing slopes, lives in small herds of 4 or 5 females, guarded jealously by a male. The most apparent difference between males and females is in their horn structure. The males have flat, bony plate-like horns which they use to buffet one another in their frequent fights for herd dominance. The females' pointed pyramidal horns are much more deadly and are used to defend themselves and their young against predators. While the herd grazes, the male normally stands on a promontory watching for signs of danger. When it sees an intruder, the male signals by erecting its long flag-like tail and the herd makes for the shelter of a nearby crag or cave. One of the deadliest predators found in the African European mountains is the chirac, a carnivore related to the weasel-like pantherate of the northern coniferous forests. Sure-footed over difficult rocky terrain and well camouflaged by its mottled gray fur, it is the groth's principale enemy. The chirac hunt in packs, surrounding their prey, or cornering them in ravines, sharing the kill among themselves. Perhaps the strangest mammal found in this region is the parashrew. The adults are unremarkable small shrew-like creatures, but the juveniles possess one of the strangest devices found in the animal kingdom. At the end of their tails, they have a fantastic parachute structure formed of interwoven hair, which they normally use only once before discarding. When the time comes to leave the parental nest, they launch themselves into the air, relying on the thermal currents that rise from these bare rocky slopes in summer to carry them to a fresh habitat, in some cases several kilometers away. As a means of dispersal, this is a bit hit and miss, but the inevitable high death rate that this behavior produces among young parashrews is more than compensated for by the large numbers of offspring produced by each adult breeding pair. The evolution of the parashrew's parachute tail is primarily due to the creature's insectivorous ancestry. It is thought that these early creatures used their tails as balancing organs when leaping to catch insects in midair. The parachute consists of soft, curled hairs hooked together to form a mat and held in shape by a series of bristles growing from the tip of the tail. The principale desert areas of the world are found in the 2 subtropical belts between latitudes 10 degrees and 35 degrees north and south of the equator. Very little land in the southern hemispheres lies between these latitudes, with the exception of the southernmost tip of the African subcontinent and the narrow tail of the South American island continent, and therefore the major deserts of the world lie in the northern hemisphere. Desert conditions are characterized by extreme dryness, annual precipitation is less than 25 centimeters, and the sun evaporates all water that falls as rain. The lack of moisture reaching desert areas is due to a number of factors. The principal one is the descent of dry air from the upper atmosphere, a feature of the global circulation pattern that is typical of these latitudes. Air is drawn to the low-pressure zones in equatorial regions, where it is heated and forced to rise. In the upper reaches of the atmosphere, the air spreads out from the equator, cools gradually and descends, reaching the ground in desert areas, where it has a very low water content. In some cases, a desert may owe its existence to being situated in the heart of a continent, far from any marine influence or moist wind. Allied to this is the rain shadow phenomenon, found in areas where air currents from the sea cross high mountains, dropping their rain on the seaward side is completely dry, giving rise to a desert area. The intensity of solar radiation in the desert is very great in comparison with other areas. In moist regions, up to 60% may be reflected away by clouds, atmospheric dust, water and plant surfaces, but in deserts only 10% of the total radiation is reflected in this way. On the other hand, due to the lack of insulating cloud cover, up to 90% of the accumulated heat of the day is lost at night through the radiation. The result is an extremely large temperature difference between day and night, which may be as great as 40 degrees Celsius. The worldwide extent of deserts is now much smaller than was the case during the Age of Man. For one thing, there is a smaller area of land lying within the desert belts than there was then, due largely to the movement of the Australian continent northwards out of the desert belt. Also in man's time, inefficient agricultural techniques and widespread grazing of domestic animals on poor land artificially enlarged the desert regions and was one of the factors that led to man's ultimate decline. With the desert becoming more extensive year by year, the area of the Earth's surface suitable for cultivation decreased. After man's disappearance, the Earth's natural habitats re-established themselves and the deserts resumed their natural proportions. Life in the desert has to cope with many hostile factors, such as lack of water and extremes of temperature. Even so, a large number of animals and plants have evolved to cope with them successfully. Similar compensating adaptations, such as highly efficient kidneys producing particular concentrated urine, large ears to dissipate heat and the ability to burrow to depths at which conditions are less severe, have been developed independently in many widely separated groups of animals in different areas of desert. Survival in a waterless sea. The physiology of desert animals must tread a narrow path between water conservation and heat regulation. The lack of sweat glands, a water-saving measure, means that less conventional ways must be used to cool the animal in the heat of the day. Usually this is achieved by large ears, so similar outgrowths which, crisscrossed by blood vessels, act as radiators to remove to animals' body heat. A structure of this kind is found on the tail of the sand flapjack, a fairly large rodent found in sandy areas. Its excess body heat is carried away by the blood to the tail, where it is dissipated into the atmosphere. When pursued, the animal can move at speed, running with its lengthy tail held well out behind as a counterbalance in the manner of its ancestor, the jerboa. To conserve water, the flapjack even constructs a condensate trap. As part of their courtship ritual, each pair of flapjacks places a pile of stones over the site of the family burrow. These stones, as well as protecting the burrow from the sun's direct rays during the day, provide a large number of cold surfaces on which moisture can condense at night. On very cold nights, so much moisture collects that it drips through to form a pool in the burrow below. The sand flapjacks cooperate in moving stones to construct their condensation traps. Although it is held out behind when running, it holds its tail aloft to catch the cooling breeze when standing still. The spitting featherfoot is a rodent of a type that has existed in this environment ever since mammals first colonized the hot, dry areas of the Earth's surface. It has small forelimbs and long hind legs, for jumping. The toes are fringed by short, stiff hairs. Its kidneys are highly efficient, recycling the animal's waste water to the point that its urine is more than twice as concentrated as that of a rodent of similar size living in a humid environment. By foaming, the spitting featherfoot both cools itself and gets rid of unwanted toxins. The leaping devil, an insectivore with carnivorous habits, has a morphology and physiology similar to the ancient jerboa and to the other small desert rodents on which it preys. It is armed with long talons and a mouthful of sharp teeth. When pouncing on its prey, the leaper devil may travel up to 2 meters in a single jump. A totally different, but one also descended from insectivore stock, is the desert shark. It is sausage-shaped with a blunt, strong head and powerful shovel-like feet. It swims through the sand rather than burrowing, bursting into the rodent's nesting chambers, which it locates using the sensory pits at the end of its nose. It is almost completely hairless and avoids the extremes of temperature by remaining underground for most of the time. When it is at rest, it lies just below the surface with only its eyes and nostrils protruding. The problem of size and its solution. The extinction of the camel at about the same time as man died out left a niche that was distinctly unattractive to any other animal. For a large animal to exist in desert conditions, a quite remarkable physiology is required. The camel, of instance, was able to lose about 30% of its body weight through dehydration without ill effects, and it stored all the subcutaneous fat of its body in one lump, leaving the rest of the body free to radiate heat. It could tolerate fluctuations in its body temperature to some extent and had thick nostril covers and eyelids that effectively kept dust and sand out of its nose and eyes. After some 50 million years of evolution, these features have all developed again in one animal, the desert leaper. The leaper is descended from the rodents, possibly one of the jerboas or sand rats, and has grown large. Adult males may reach more than 3 meters from nose to tail. The tail is most unusual feature of this animal. It is here that all its subcutaneous fat is stored. The fat is not a water store, but a store of food that enables the leaper to go for long periods without eating when food is unavailable. When the fat store is full, the animal's body is well balanced and it can leap quickly along its hind limbs. In this condition it can undertake journeys of 100 kilometers or more between waterholes and oases. It has broad, horny pads on the toes of its hind feet which prevent it from sinking into the sand and give it a good grip on naked rock. The desert leaper stores fat in its tail. It can survive for up to 3 months without food. It eats mainly the leaves of desert shrubs and receives most of its moisture needs this way. It can lose 50% of its body weight without lasting ill effects. Both male and female have heavy eyelids and retractable nostril covers as protection against sand. The rocky areas of the desert are the habitat preferred by the grobit. This rodent is about 60 centimeters long, excluding the tail, and has hooves developed on its third and fourth digits enabling it to run about the craggy landscape of the rocky desert. The second and fifth digits of its front feet have small claws that almost touch the hooves when the foot is bent, allowing the grobit to grasp and pull down branches and feed on them. It lives in packs all over the rocky desert zone of the African and Asian subcontinents. It is purely herbivorous. Its long tail may grow to over 1 meter. It feeds mainly on the leaves and shoots of desert shrubs. Its cloven hoofs and dew claws are used in conjunction to grasp branches. In the deserts, large predators are not common and very few meat-eating mammals of any description are found. The killa, however, descended from the insectivores, is one of the few. Standing about 60 centimeters high at the shoulder, it is largely nocturnal and spend most of the day hidden in a network of burrows excavated in soft sand. At night it hunts small mammals and obtains most of the water it needs from the moisture contained in their flesh. Animals that are not camouflaged are predominantly black. Predatory birds, reptiles and the most poisonous and unpalatable arthropods fall into this category. The color resemblance may be due to a form of mimicry in which for some reason black is an advantageous color for certain predators, and all others adopt the same color to derive some similar benefit. The criskin, a common predatory bird in desert areas feeding principally on snakes, is, like many other predators of the region, mainly black in color. Living in the shadow of the mountains. The North American deserts are rain shadow deserts. The wet westerly winds that blow towards the continent across the Pacific Ocean first meet the Great Western Mountain Barrier and are forced to rise, dropping their rain on the seaward side. Past the peaks the winds are dry and desert conditions prevail on the extensive plains beyond. The deserts are not completely barren, but contain an intermittent vegetation consisting of cacti and other succulent plants, normally growing as single specimens, each widely separated from one another. The barren soil surface between the plants conceals a vast network of roots spreading out to collect enough water for each plant to survive. Among the roots lives the rootsucker, an animal heavily armored to protect it from desiccation rather than to defend it from attack. Its head is shielded by a broad spade-like plate and its back is covered by a shiny nut-like shell composed of compacted hair. Its tail and feet are also armored, but with articulated plates that permit total mobility. The rootsucker moves through the sand using its broad feet like paddles and its head shield as a shovel to reach the roots of succulents on which it feeds, gnawing them with the edge of its head shield and lower incisors. It is equipped for digging with long, pointed claws and a horny head shield. Lizard and other reptiles do not have the sophisticated mechanisms that mammals and birds have for regulating body temperature. Their temperature is entirely dependent on the surroundings. Several desert reptiles have, however, developed rudimentary devices for keeping themselves cool. The fin lizard, for instance, a small bipedal reptile, has a system of erectile fins and dewlaps on its neck and tail which it raises into the wind when its body becomes too hot. The heat is transferred through the fins via the bloodstream into the air. When cooling itself, the lizard typically balances on one leg while keeping the other off the hot desert surface to get maximum benefit from the system. The neck fins are full of blood vessels that lie near the surface and serve to keep the animal cool. The fin lizard can travel at speeds up to 50 km per hour. Between the fierce aridity of the desert belt and the constant humidity of the tropical forest regions lies an area where the rainfall is intermittent and erratic. The dominant plants are grasses and the habitat is one of open plains with scattered scraps of brush and woodland. As the region lies wholly within the tropics, the sun is therefore directly overhead at any one place on 2 occasions each year. Most of the rainfall comes at these times because the tropical convergence of global winds and the wet conditions associated with them move north and south with the sun twice every year. The intervening dry seasons are due to the dry high-pressure belt associated with the deserts moving over the grassland area. The dominance of grasses over trees has more to do with the level of soil moisture than it has more to do with the total amount of rainfall. Typically only the upper soil layers contain water, whereas the lower strata, where tree roots would be found, remain dry all year. Some areas of grassland receive substantial amounts of rain, but because it occurs only at certain times of the year, trees are unable to establish themselves. Because of the general dryness of the region, it is highly susceptible to fire. Indeed, it is repeated destruction by frequent grassland fires that has produced the plants that are characteristic of the habitat. The trees are particularly hard and fire resistant, and the grasses grow from their bases rather than from the tips of their leaves and stalks. They also spread by means of underground runners, which allows their instant recovery after fire has swept the area and destroyed the exposed parts. The rapid recovery of trees and grasses from damage permits the grasslands to support large numbers of grass-eating animals despite the frequent fires. Only the upper parts of the leaves and stems are eaten, leaving the growing bases and the underground runners intact. Another feature of the grasslands that has an important influence on the fauna is the sparseness of cover. A grazing animal can therefore be seen by a predator from a great distance, and conversely the grazing animal can see danger coming. Hence both grazers and predators in these regions are highly adapted for speed and pursuit, and have long legs and quick reactions. Some birds, too, have found that they can survive on the grasslands using only their legs to take them out of trouble without recourse of flight. Another feature of tropical grassland life is migration. Because of the seasonality of rainfall, different areas of the grasslands provide food at different times of the year, and hence great migrations of grazing herds occur throughout the year. Migration also takes place to the grasslands from other parts of the world. Many birds summer in the temperate woodlands, far to the north, and fly south to the grasslands to escape the winters. As with the desert belts, the total land area of the globe lying within the tropical grassland climatic belt has diminished since the age of man due to the constant northward movement of the Australian continent. Although the largest extent of tropical grassland is on the African subcontinent, considerable expanses also exist on the South American island continent south of the equatorial rainforests. Ground-dwelling birds and herbivorous herds. The grasslands, both tropical and temperate, are the home of the running animals. The long vistas and the general lack of cover make concealment difficult, and speed is the most practical means of defense. The grasslands first appeared on a large scale about 80 million years ago, when a general reduction in the area of forest found on the Earth. At this time the mammals that had been in existence for about 20 million years developed running forms in large numbers for the first time. The grasses, representing a vast untapped food source, had however a high silica content, which made them much tougher than the leaves of trees to which the browsing mammals were accustomed. To deal with this more fibrous material, new tooth structures appeared that had hard enamel ridges and cusps to grind down the grass before it was swallowed. New, elaborate digestive systems were also evolved to deal effectively with it. By the age of man, the long-legged grazers, the ungulates such as the zebra and the gazelle, were the most successful animals of the tropical grasslands. However, the rabbits, which originated in the temperate woodlands, after man's extinction, spread southwards, round the mountain barriers, into the African and Indian subcontinents, where they flourished and competed so effectively with the ungulates that in time they largely replaced them. Although many forms of rabbit inhabit the same region, because of their different feeding habits they do not compete directly with one another. The little picktooth feeds on low-growing herbs and roots, which it digs up with its tusks and spurs. Its second incisor teeth are developed into strong laterally directed tusks, and it has long spur-like claws on the fourth digit of each forefoot. As it runs only on the second and third toes of each foot, the spurs do not hinder it. The taller grasses are grazed by vast herds of larger rabbits. They tend to be similar to their temperate cousins, but are on the whole lighter in build and have longer legs and ears. Their coloration is very different, consisting mostly of pale brown and white arranged in stripes or spots depending on the species. The stank has a dazzling pattern of stripes like the extinct zebra, while the larger watu carries large angular blotches similar to those once possessed by the giraffe. Such patterns make individuals merge into one another so that a distant predator gets only a confused impression of the herd as a whole. It is particularly effective in thorn thickets and areas of scrubby woodland. All rabbits, whether temperate or tropical, retain the dazzling white tail of their rabbit ancestors. It is used as a warning signal when the herd is attacked. The strank stripes produce a confused impression from a distance. Botched markings give the watu camouflage in areas of scrubby woodland. The tropical grasslands are the home of a species of large flightless guinea fowl. Standing about 1.7 meters high, it sports a startling selection of erectile wattles and inflatable throat pouches, which are used in threat display when dominance or pecking order is threatened. It is an omnivorous bird and feeds on seeds, grasses, insects and small reptiles. Although it can deal a lethal blow with its broad feet in common with most plains-dwelling animals, it runs off when real danger threatens. The flightless guinea fowl is found in the African subcontinent south of the equator. It is one of the fiercest and most territorial of all tropical ground-dwelling birds. Except for the color of their legs, there is little difference between males and females. Males have pink legs and females have blue. When threatened, the guinea fowl inflates its throat pouch, arches its neck far back until it nearly touches its back and utters a shrill, throaty scream. Mating occurs in the early summer and normally results in 1 or 2 eggs being laid 5 or 6 weeks later. The incubation is shared by both males and females. The place of large herbivores in a tropical environment. The elephants flourished throughout the first half of the age of mammals, but with man's appearance their number fell until they had almost become extinct. 2 genera only, Elephas and Loxodonta, were latterly contemporaries of man, and both of these died out shortly before man's disappearance, leaving no descendants. The ecological niche which they vacated was eventually filled by the descendants of a surviving group of antelopes, the gigantelopes. These enormous creatures with tree trunk legs and weighing up to 10 tons became the giant herbivores of the tropical plains, a group of animals feeding on trees, grasses or roots depending on the species. They had long since abandoned the antelope's running gait and had instead taken up a plodding existence, the 2-toed feet of their ancestors having become broad-hooved pads. The typical grassland-dwelling type, gigantelope, has 4 horns, 1 pair curving down behind its ears and another pair pointing out in front of its snout. Each horn has a pick-like point, enabling the animal to scrape soil away from the plant roots and bulbs on which it feeds. At first glance, these massive beasts seem to contradict the general rule that animals of hotter climates tend to be smaller than their equivalents in cooler areas. The larger an animal is, the smaller its surface area is in relation to its body mass, and the more difficult it is for it to lose excess heat. In the case of gigantelopes, however, this problem is overcome by the possession of a large dewlap beneath the neck, which is well served with blood vessels and effectively increases the creature's body area by about 1/5, thus providing an efficient heat radiator. The rhinoceros, another of the massive tropical grassland animals that became extinct during the Age of Man, has an almost direct equivalent in the gigantelopes, the rundihorn. It has adopted a body size and a horn arrangement not unlike its predecessors and is a grazing animal, a fact that is reflected by its broad snout and muzzle. Its alarming horn array is used for defense, although the animal has few enemies likely to risk a frontal attack. For the males, however, its secondary function, for sexual display, is now more important. Predators and scavengers of the plains. Although the 2 principal predators of the tropical grasslands of the African subcontinent are both primates, they have evolved along very different lines and hunt different prey. The horan is descended from the tree-dwelling apes of the tropical forests, a fact indicated by the way that the animal walks on the knuckles of its forefeet. It leads a totally ground-dwelling carnivorous mode of life. Lying in the long grass, where it is camouflaged by its stripes and mane, it waits for its chief prey, the gigantelope. As they pass by, the horan leaps out onto the back or neck of its quarry, using its sickle-like claws to rip deep wounds around the neck and throat. Severely wounded, the gigantelope soon dies, providing a meal for the whole horan family group. Their hunting strategy relies heavily on concealment and the element of surprise. The raboons descended from the baboons that flourished on the grasslands during the Age of Man. Their diet changed from omnivorous to carnivorous during the period that the big cats of the grasslands died out. At the same time they increased their speed by taking to their hind limbs and adopting a totally bipedal locomotion. The forelimbs became reduced and the head was carried further forward, balanced by a thick, heavy tail. In physical form the raboon bears a distinct resemblance to the carnivorous dinosaurs that died out more than 100 million years ago. A number of species of raboon, each living on a different species of prey, exist in family-based tribes, like the ancestral baboons. Carnipapio longippes is a very small, lightly-built species about 1 meter high that hunts smaller animals. Carnipapio vulgaris is the most widely ranging species and preys on the rabbit herds. Carnipapio grandis is the most massive member of the genus. It stands about 2–3 meters high at the hip and lives purely as a scavenger. As predators such eat only the softer tissues and muscles of a carcass's belly and anal regions, there is always plenty of meat left for the scavenger. The giant raboon concentrates on the meat of the limbs and neck, leaving the rest to smaller, less powerful carrion feeders. The most efficient scavenger of the African grasslands is the gull, a creature that resembles a large mongoose. Its head and neck are almost totally devoid of hair, allowing it to reach inside the body cavities of carcasses without its coat becoming fouled. Its canine teeth are particularly huge and are capable of crushing most bones to get at the marrow. Gulls live in packs of about a dozen and have developed an almost symbiotic relationship with a species of termite. This termite builds its mound with a horizontal shelf projecting out all round, a meter or so above the ground. The shelf provides shelter from the fierce midday sun where the gull can bring bones and other tough parts of its meal of chew at leisure. The termites feed on the scraps of carrion that the gull invariably leaves scattered around the mound, thus benefiting from the relationship. It usually takes about 3 days for the predators and scavengers of the grasslands to reduce a gigantelope to no more than a few pieces of bone and hide and a patch of stained, trampled ground. The final remnants are consumed by insects and microorganisms. The tropical forests are found in a broad belt encircling the world at the equator, broken only by oceans and mountains. Their distribution coincides with the band of low-pressure areas that occurs where rising tropical air is replaced by moist air flowing in from the north and south to form a system of converging winds. The rainforest is the floral product of great heat and copious moisture. At all times the average temperature must be between about 21 degrees and 32 degrees Celsius and the annual rainfall in excess of 150 centimeters. As the sun is roughly overhead throughout the year, the climatic conditions have a constancy found in no other habitat. Tropical forests are often associated with great rivers, which carry away the copious rainfall. Such rivers are found in the South American island continent, the African subcontinent and the subcontinent of Australia. Despite the constant fall of discarded leaves, the soils of the rainforests are very thin. The conditions are so favorable for decomposition that humus does not have a chance to form. The tropical rain washes the clay minerals out of the soil, preventing important nutrients such as nitrates, phosphates, potassium, sodium and calcium from being retained as they are in temperate soils. The only nutrients found in tropical soils are contained in the decomposing plants themselves. There are many variations on the basic form of tropical forest resulting both from climatic and local environmental differences. Gallery forest is found where the forest comes to an abrupt halt, as at the edge of a broad river. Here the branches and leaves form a dense wall of vegetation recking to the ground, to take advantage of light coming in from the side. Less luxuriant monsoon forests exist in regions where there is a distinct dry season. They are found at the edge of continental areas, where the prevailing winds blow from the dry interior at one particular time of year, and are typical of the Indian Peninsula and parts of the Australian subcontinent. Mangrove forest is found in saline swamp areas along muddy shorelines and the mouths of rivers. There are no dominant species of trees in the tropical forest as there are in other forest habitats. This is because there are no seasons and therefore the insect population does not fluctuate. The insects that feed on a particular species of tree are always present and will destroy the seeds and seedlings of that tree if they are sown nearby. Therefore the only seeds that flourish are those that are transported some distance away from their parent and its permanent insect population. In this way stands of particular tree species are prevented from forming. The area of tropical forest has increased considerably since the age of man. In the past, a great deal of damage was done to the habitat by man's agricultural practices. Primitive societies cut down areas of trees and farmed the clearings for a few years until the thin soil became exhausted, compelling them to move on to another area. In the cleared areas, the original forest did not immediately re-establish itself, and it was many thousands of years after man's extinction before the tropical forest belt returned to anything like its natural condition. A world of gliders, climbers and perchers. The tropical forest is one of the most luxuriant habitats on Earth. The high rainfall and stable climate mean that there is a perpetual growing chanson, and there are therefore no periods in which there is nothing to eat. The copious vegetation, thrusting upwards to reach the light, although continuous, is arranged very roughly in horizontal layers. Most photosynthesis takes place at the very top, in the canopy layer, where the tops of the trees branch out to form an almost continuous blanket of greenery flowers. Beneath this the sunlight is more diffused, and the habitat consists of the trunks of the taller trees and the crowns of those that do not quite reach the canopy. The forest floor is the gloomy domain of shrubs and herbs, which crawl out to make the best use of the little light that filters down. Although the tremendous variety of plant species supports an equal diversity of animal species, the number of individuals in each is comparatively small. This situation is exactly the opposite of that found in harsh environments such as the tundra, where, because few life forms can adapt to the conditions of the region, there are many fewer species of either plants or animals but correspondingly more individuals in each. As a result, the animal population of the tropical forests remains stable, and there are no cyclical plagues of either predator or prey species. Birds of prey such as eagles and hawks are the important predators of the tree tops, as they are in any other habitat. The tree-living animals of these regions must be swift enough to elude them and also to escape from tree-climbing predators coming up from below. The mammals that accomplish this best are the primates. The long-armed zebra of the African subcontinent has taken these specializations to the extreme, and has developed long arms and legs, fingers and toes, so that it can brachiate, or swing, its tiny globular body through the branches of the trees at high speed. It has also evolved a prehensile tail, just as its South American cousins did in the first half of the Age of Mammals. Its tail, however, is not used for locomotion but only for hanging from when resting or asleep. It curls itself into a ball to sleep. First it wraps its arms across its body and then brings its legs close in against its chest. The flunkey, a very small marmoset-like monkey, has become adapted to a gliding mode of locomotion. In this development it parallels the evolution of many other mammals that have evolved gliding wings, or patagia, from holds of skin between the limbs and tail. To support the patagia and deal with the stresses involved in flight, the backbone and the limb bones have become remarkably strong on an animal of this size. Steered by its rudder-like tail, the flunkey makes great gliding leaps between the crowns of the highest trees to feed on fruit and termites. Among the tree-living reptiles of the African rain-forest, perhaps the most specialized is the anchorwhip, an extremely long and thin tree snake. Its broad, grasping tail, the most muscular part of its body, is used to anchor it to a tree while it lies coiled and camouflaged among the leaves of the tallest crowns in wait for an unwary passing bird. The snake is capable of darting out 3 meters, equivalent to about 4/5 of its body length, and seizing its prey while still retaining a tight hold on the branch with its tail. The evolution of life under threat. During most of the Age of Mammals, the apes and monkeys enjoyed a degree of security among the tree tops. For even though there were some predators, none was adapted to prey on them specifically, but that was before the striger. This fierce little creature developed from the last of the true cats about 30 million years ago and spread throughout the rain forests of Africa and Asia, its success hinging on the fact that it was as well adapted to life in the trees as its prey. The striger even adopted the bodily shape of the monkeys on which it fed, a long, slender body, forelimbs that could swing apart to an angle of 180 degrees, a prehensile tail and opposable fingers and toes that allowed it to grasp the branches. While most of the cat family, the striger has gasping claws. A pad of hairless skin at the tips of the tail is used for gripping branches. The clatta, a lemur-like prosimian with a heavily armored tail protected by a series of overlapping horny plates, demonstrates this principle. Before the arrival of the tree-living predators, such a tail would have been a disadvantage, interfering with the efficiency of food gathering. Any tendency for such a cumbersome structure to evolve would have been quashed rapidly by natural selection. But faced with constant danger, the efficiency of food gathering would have taken on an importance secondary to defense and would have therefore created the correct conditions for it to evolve. The clada is found in the lower branches of tropical trees. When attacked, it drops down, presenting the predator with an impenetrable horny plate tail. The kiffa is a monkey whose defense is based on its social organization. It lives in tribes of up to 20 individuals and builds defensive citadels in the boughs of trees. These large, hollow nests, woven from branches and creepers and roofed with rainproof thatch of leaves, have several entrances, usually situated where the main branches of the tree thrust through the structure. Most of the work of food gathering and building is carried out by females and young males. The adult males remain behind to defend the citadel and have developed a unique set of features to carry out their highly specialized role: horny armor over the face and chest and vicious claws on the thumb and forefinger. Males kiffafs are equipped primarily for defense, female and young's posses neither armor nor claws, they are the colony's principal food gatherers. Their nest is divided into 2 levels containing separate storage and living spaces. The whole structure is roofed with a full thatch of leaves. The twilight zone of the woodland life. Compared with the canopy layer, the floor of the tropical rainforest is a dark, humid place. Little light penetrates through from the trees' tops, and although there are many shrubs and herbs, they nowhere present a thick, impenetrable barrier. Despite a steady fall of dead leaves from above, the soil cover is very shallow. The vegetable material on the ground is under constant attack from microorganisms and from the ubiquitous termites that perform a broadly similar function to that of the earthworms in temperate latitudes by keeping the debris circulating. The termites are the principal food source of the termite, one of the few large mammals found on the African rainforest floor. It is descended from the pigs that were once common in this environment. In the termite, the tusks of the upper jaw are projected forwards, elongating the snout still further, and have turned outwards to produce strong pig-like instruments with which it digs into termite mounds. The lower jaw has lost all its teeth and musculature, and the mouth has diminished to a tiny hole through which sticks out its ribbon-like tongue to gather termites. It digs for food with its clawed front feet and tusks. From the same ancestral pig stock as the termite comes the zarander. This much larger vegetarian animal lives on the sparse herbs and shrubs found in less dense areas of the forest floor. Its long trunk, developed from a snout similar to the trunk of the ancient elephant, enables the zarander to reach leafy branches 4 meters above the ground, where it can snip branches and vines from the trees by the scissor action of its upper and lower tusks. Despite its long nose, the zarander has little sense of smell. Like other mammals of the forest floor, the lack of wind and general circulation among the dense trees means that scents do not travel far. Relying on its keen hearing to warn it of the approach of an enemy, it takes off into the thicker parts of the forest at the arrival of a predator, squeezing its narrow body between the tree trunks, and remaining motionless, camouflaged by its stripes and dark body color. Zaranders live in small herds of up to 8 in number. Each herd usually contains only 1 adult male. It is particularly fond of young leaves and shoots. Its long trunk gives it an advantage in feeding over other ground-dwelling herbivores. One of the smaller mammals of the African tropical forest is the trovamp, a parasite which sucks the blood of larger mammals. The trovamp is built rather like an insectivore or one of the smaller prosimians. It is very agile, climbing about, usually in packs, among the trunks and the branches of the shrubs. It is a prodigious jumper and can leap 3 meters from a branch to bury its needle-like jaws into the hide of a passing animal. Its protruding canine teeth act as barbs and prevent it from being dislodged from its host until it is finished feeding. As many as 10 trovamps may parasitize one host and will remain feeding until the animal is severely weakened. Clinging to the trunks of trees with their clawed fingers, trovamps are ideally placed to leap, dart-like, onto their prey. On each jaw the trovamp has 2 barbs, formed from the canine teeth. When the jaw is closed they protrude to give the appearance of tusks. The most remarkable from the point of view of social behavior is the giant pitta. The male pitta, unusually for a bid, is about 3 times the size of the female and each year takes a harem of 3 or 4 females. Each female builds a separate nest in the same vicinity and relies on the male to provide her with food during the breeding season. The male also provides protection from predators as well as defending the harem against rivals. Creatures of the tropical wetlands. The largest aquatic mammal of the African swamplands is the mud gulper. Although it is derived from a water-dwelling rodent, it shows adaptations that closely parallel those of the extinct ungulate hippopotamus. Its head is broad and its eyes, ears and nostrils are located on bumps on the top so that they can still operate even when the animal is totally submerged. The mud gulper eats only water plants, which it scoops up in its wide mouth or scrapes up from the mud with its tusks. Its body is long and its hind feet are fused to form a flipper, giving it a seal-like appearance. Even though it is very clumsy out of the water, it spends much of its time on mudbanks, where it breeds and rears its young in noisy colonies at the water's edge. The mud gulper lives largely on water plants which is dredges from the muddy bottoms of rivers and lakes. On land it tucks its tail under its body. Its tail is studded with horny pads that strengthen and support it out of the water. Less well adapted but nevertheless efficient in the water is the swimming monkey. Descended from the swamp monkey of the Age of Man, this creature has developed a frog-like body with webbed hind feet, long, clawed fingers for catching fish and a ridge down its back to give it stability in the water. Its sensory organs are placed high up on its head. It lives in riverside trees, from which it dives to catch the fish that are its staple diet. Land-dwelling animals that have taken to an aquatic mode of life have usually done so initially to escape land-dwelling predators. This is probably why the water has taken to building its huge nest on rafts in swamps and quiet backwaters. Each nest is made of twigs and fibrous vegetable material, waterproofed by a plaster of mud and bodily excretions. It is connected to the banks and to floating food stores by a network of bridges and ramps. However, in their new mode of life the ants are still vulnerable to the swimming anteater, which has evolved in parallel with it. The anteater lives solely on the water ants, and to reach them undetected it attacks the nest from below, ripping through the waterproof shell with its clawed paddles. Since below the waterline the nest is made of discrete chambers that can rapidly be made watertight in an emergency, little damage is done to the colony as a whole. The ants drowned in an attack, however, are enough to feed the anteater. Marsupial climbers and marsupial predators. Beyond the mountains of the Far East, the most extensive and the highest chain in the world, greater even than the Himalayas at their zenith 50 million years ago, lies the great Australian subcontinent. The conditions in this areas today, lush tropical forests occupying vast river basins, make it difficult to believe that a mere 100 million years ago this landmass was part of the Antarctic continent. When at this time Australia split off and began drifting northwards, the age of mammals was well underway and the continent already all marsupials, mammals that nursed their young in a pouch on their abdomen, and because of Australia's long history of isolation have largely remained so. In the rest of the world, however, the marsupials were gradually superseded by the placentals, mammals not giving birth until their young are more fully developed. By the Age of Man, Australia had reached the desert and tropical grassland latitudes, where the conditions provided the evolutionary impetus for the development of running and burrowing animals such as the kangaroo and the wombat. After man the continent continued its drift northwards until, sometime in the last 10 million years, it collided with the mainland, throwing up the Great Barrier Mountains have exist today. Although some diffusion of animals has taken place between Australia and the rest of the northern continent, the mountains have kept this cross-traffic to a minimum and the subcontinent still has a predominantly marsupial fauna, albeit one adapted to the tropical forests. As in previous ages the Australian marsupials have developed forms that are superficially very similar to those of placental creatures existing in similar environments in other parts of the world. A prime example of this is the chuckaboo, essentially a marsupial monkey with grasping arms and legs, opposable digits and a prehensile tail. Its bodily form, similar to many of the true monkeys in other parts of the world, is well suited to life in the trees. The chuckaboo female has two pouches, one on either side of her abdomen, so that her young do not get in the way when she is climbing. A less energetic tree dweller, the slobber, can be thought of as a kind of marsupial sloth that spends nearly all of its life hanging upside down from trees and creepers. It is totally blind and subsists entirely on insects that it catches in the flowers of its home creeper by entangling them in long strands of mucus dangled from its mouth. Its large downturned ears and sensory whiskers alert it to an insect's arrival and tell it when to drop the mucus, which it aims at the flower's scent. As the slobber's hair grows in spiral tufts and is pervaded by a parasitic algae, it is completely camouflaged against the background of creepers, and when totally motionless can escape the attention of predators. The hiri-hiri, despite the fact that it is a tree dweller, is also highly efficient in preying on ground-living animals. Lying in wait on a low branch, it dangles its strong prehensile tail down like an innocent vine. When some unsuspecting animal trots by, the hiri-hiri seizes it swiftly with its tail and strangles it. It is descended from the Tasmanian devil. Life on the forest floor. The floor of the Great Rain Forest of the Australian subcontinent is home for a number of marsupial mammals. One of the most generalized and successful of these is the omnivorous posset, the marsupial equivalent of the tapir. Like its placental counterpart, it wanders through the gloomy undergrowth in small herds, snuffling and scraping for food in the thin soil with its flexible, sensitive snout and protruding tusks. Cryptic coloration helps to conceal it from its enemies. The posset, a forest-dwelling marsupial pig, has 4 tusks, 2 projecting from its upper jaw and 2 from its lower jaw. It forages in the soil with its long snout for roots and grubs. The largest animal of the Australian forest, and in fact the largest animal found in any of the world's tropical forests, is the gigantala. This animal has evolved from the plains-dwelling kangaroos and wallabies that were common when much of the continent was semi-arid grassland, and betrays its ancestry by its upright stance and peculiar loping motion. The gigantala is so large that it seems at first sight ill-adapted to life in the confined conditions of the tropical forest floor. However, its great height does give it the other forest inhabitants, and its bulk means that shrubs and small trees do not impede it. As the gigantala crashes through the thickets, it leaves behind well-marked trails, until they are reclaimed by the natural growth of forest, are used as trackways by smaller animals. The herbivorous gigantala plucks at the leaves of trees with its long tongue. When drawn erect, a fully mature individual stands over 3 meters high. Its muscular tail acts as an extra leg, bearing the creature's weight when standing upright. Isolation is one of the most important mechanisms of evolution. When a group of creatures becomes separated from the main breeding population, the separated group evolves independently of the parent group because there is no longer any possibility of interbreeding. The new group interacts with its environment, totally closed to it if it were living among its original enemies and competitors. This phenomenon is particularly marked where animals become isolated in sparsely or hitherto unpopulated areas and is nowhere better seen than on the islands of the oceans. There are 2 main varieties of isolation in this context, each producing its own environmental pressures and giving rise to its own forms of evolution. The first takes place when one continental mass splits away from another. What then happens to their fauna is largely dependent on the subsequent movements of the 2 continents. One land mass may drift northwards or southwards with respect to the other, subjecting its fauna to new climatic and environmental conditions which could affect their evolution and ultimately lead to the production of totally new genera and species. Exactly this happened during the Age of Reptiles, when the South American continent, which had shared the same dinosaur fauna as Africa, split away, resulting in the evolution of totally different animals in each area. When a drifting continent collides with another, very often a considerable interchange of faunas takes place between the 2 land areas. It may happen that the fauna from one continent completely replaces that of the other. This happened when the small continent that is now the Indian Peninsula collided with mainland Asia. The second form of biological isolation occurs when a completely new group of volcanic islands is formed. In plate tectonics, much of the activity between adjacent crustal plates takes place in the open ocean. New plates are created along the mid-oceanic ridges and are destroyed as they slide beneath one another in the deep oceanic trenches. Such violent activity produces earthquakes and volcanic eruptions, creating new islands from the ocean bed. The volcanic islands, quite barren to begin with, are soon colonized by living organisms. Plants, germinated from wind-blown seeds, are usually the first to arrive and take hold, followed by the insects. The first vertebrate inhabitants are usually flying creatures such as birds or bats. Only later do the other vertebrates, usually reptiles and small mammals, arrive, sometimes on floating branches and tree trunks, the result of some river flood hundreds of kilometers away. All these creatures then evolve independently of their ancestral continental stock to fill all the ecological niches of the island. The classic example of this sequence is the colonization of the Galapagos Islands off the west coast of South America during the early part of the Age of Mammals. These islands were initially populated by a small number of species, which gave rise eventually to a vast array of new creatures, including four-eyed fish, marine lizards and giant tortoises. The island's fauna, particularly the inter-island differences between related species, was thoroughly investigated and stimulated the development of evolutionary theory. The effect of continental drift on animal communities. Although during the first half of the Age of Mammals South America did have a small population of primitive placental mammals, it was, like Australia, a bastion of the marsupials. However, just before the Age of Man, a land bridge was established between South America and North America which led to an exchange of faunas between the two areas. The result was that the placental mammals from the north, being more versatile, almost entirely replaced the marsupials and the primitive placentals of the south. The northern fauna were more versatile because they had been subjected to greater selective pressures in the preceding 50 million years. They had been compelled to adapt radically in the face of changing environmental conditions brought about by such factors as ice ages and faunal exchanges with Asia. The result at the time of the collision with South America was a very hardy and adaptable stock of animals. The mammals of South America, on the other hand, had experienced a stable unchanging environment during the same period and therefore lacked this essential adaptability. A similar fate did not befall the marsupials of Australia, since that continent, in drifting northwards, presented its fauna with constantly changing conditions, resulting in a population of hardy species that were able to survive the faunal exchanges that occurred during the period shortly after Australia impacted with Asia. 20 million years after the Age of Man, the land connection with North America was again broken and South America became an island continent once more. Since the split, climatic conditions on the South American continent have remained unchanged and the fauna has therefore changed very little. This conservatism is well seen among the mammalian predators, a niche that has continued to be occupied by members of the order Carnivora despite the fact that this group has declined elsewhere. The foremost predator of the South American tropical forest is the gurith, a giant hunting mongoose. Its ancestor was introduced by man to the then offshore islands at the north of the continent, where it became a pest and overran them. When the islands became fused to the mainland, the mongoose spread southwards and developed into its present jaguar-like form. Tapemus is a long-tusked rodent that feeds in open areas of the forest. A much smaller carnivore, the night glider, is derived from tree-dwelling mustelid stock. During the day it hangs on trees disguised against the bark, floating down to feed upon nocturnal insects, frogs and small mammals at night. Its method of hunting is to impale its prey on the spines that project from its chest. Its erectile spines are formed from modified hairs that, in the course of evolution, have developed into stiff needle-like structures. The night glider parachutes silently down onto its quarry, impaling it on its chest spines. One of the strangest birds of these regions is the matriarch tunamu. The female of the species is a ground-living bird, very much larger than the male whom he carries around on her back. The male's wings and digestive system are degenerate and he is entirely parasitic on the female, sucking her blood through his needle-shaped beak. The male's only biological function is to provide sperm during mating. This relationship arises from the species' low population density, which makes it an advantage for each female to have a mate constantly available rather than to search for one each breeding season. Evolution on an isolated continent. Throughout its history, the movement of the crustal plate carrying the South American continent has been predominantly westwards, and hence the landmass has tended to remain within the same latitudes. This accounts for the constancy of the climatic regions and the conservatism of east fauna. During the continent's early history, the grasslands, or pampas, supported their own fauna of running ungulate animals, similar to, but totally isolated from, those in other parts of the world. These animals existed until the continent became joined by a land bridge to North America, when they and the native marsupial population were swept away completely by the influx of animals from the north. Strangely enough, the northern ungulates did not find a permanent foothold on the pampas, but rather rodents such as the maras and the capybaras present at the time of man, were the more successful. In this respect, the South American continent anticipated the rise of the advanced running rodents and lagomorphs in the rest of the world. Once the continent separated from the supercontinent of the north, the rodent fauna developed along its own lines. The running animals of the pampas are dominated by strange bipedal grazers, which are descended from the jumping rodents that evolved in the rain-shadow deserts along the western mountains. Although long hind legs evolved independently among desert rodents in other continents, only those of South America changed from a jumping to a running mode in the course of their evolutionary history. Along with this change of gait went an increase in size and a change of dentition that effected the final transition from the jumping, gnawing rodent of the desert to the striding grazer of the plains. The most generalized running rodent is the strik, which looks very much like the grazing marsupial kangaroos that once existed in Australia. They graze among the long grasses in tightly knit groups that are large enough to ensure that there are always at least 2 or 3 individuals with their heads up, looking around for danger while the rest have their senses buried in the grass. Striks are very shy creatures and for security live in small herds of up to 12 in numbers. Their markings break up their shape and make them difficult to pick at a distance. The most specialized creature of its family, and perhaps the most highly adapted running animal in the world, is the waka. Because of its bipedal stance, its forelimbs have become less important and are now completely atrophied. Its globular body and long hind legs support an equally long neck and tail which balance one another, maintaining the animal's center of gravity over its hips. These features give the creature a clear view of the surrounding countryside. Even when the waka is grazing in long grass, its eyes are placed high enough on its elongated head for it to see the approach of a predator. Wakas are such fast runners that, provided they can see a predator approaching, they are always able to outrun it. They are only vulnerable when they have their head down foraging in the grass. The flower-faced patu is the oddest bird found on the grasslands. The interior of its beak is colored and patterned like the petals of a flower, so that when it has its mouth open it looks exactly like an open bloom. This elaborate mimicry is designed to deceive insects and provides the patu with a meal by merely opening its mouth. Because tropical grassland flowers appear only when there is adequate moisture, the patu migrates seasonally with the rains. The bastion of the hoofed animals. The movements of the Earth's crustal plates that carry the continents and account for continental drift are the result of convection currents deep in the Earth's mantle. The currents can build up stresses beneath the continents which eventually tear them apart. Normally an elongated rift valley, associated with considerable volcanic activity, forms first of all along the line of the eventual split. The land on either side then separates and moves apart, an ocean area growing steadily to fill the gap. This happened when the small island continent of Malagasy split away from mainland Africa 100 million years ago, and again more recently when the whole of eastern Africa split away to form Lemuria. In the case of Lemuria, the separation occurred before the ungulate herds of Africa has been replaced by herabics from temperate latitudes. As a result, hoofed animals are as plentiful on the grassy plains of Lemuria as they ever were in Africa before the age of man. The grasses are eaten by lightly billed fleet-footed ungulates such as the snorka. The snorka has a very long head with its eyes placed near the top, an adaptation that enables it to keep a watch for predators while grazing. As the herds move across the plains feeding, they expose the lower layers of vegetation, which provide food for the smaller herbivores. The upper layer of vegetation are exploited by the long-necked yipa, which can reach the leaves and young shoots of the savanna trees. It is dependent on trees for food and migrates to the edge of the tropical forest during the dry season. The cleft-back antelope, a creature that is superficially similar to the ancestral antelope, has a curious symbiotic relationship with the tick bird. This relationship is really no more than a strengthening of the symbiosis that had developed between birds and grazing animals during the early part of the age of mammals. Birds on the grassy plains often accompanied the larger mammals, catching the insects disturbed by their hooves, or pecking ticks and mites from the hides of the animals themselves. The grazing animals tolerated this as the birds rid them of parasites and also gave warning of approaching danger. In the case of the cleft-back antelope, the relationship has become more intimate and the animal's back has ceased to be a mere perch and has become a nesting site. Along the animal's back is a pair of ridges, supported by outgrowths from the vertebrae. Between the ridges is a deep cleft lined by stiff hairs that provide an ideal nesting medium for the tick bird. Several families may nest on its back at one time. Superficial warts on the animal's flanks produce pus at certain times of the year. The pus attract flies, which lay egg in the warts. The flies' maggots appear just as the young birds are hatching and provide them with a ready-made source of food. In return, the antelope is supplied with both a constant grooming service and an early warning system that alerts it to approaching predators. An island world of bats. Although volcanic mountains and islands usually form where two crustal plates meet and crush against one another, they also form over hot spots on the Earth's crust, areas lying above intense activity deep in the Earth's mantle. Directly over the hot spot a volcano is formed. When the crust passes away from the center of activity, the volcano becomes extinct and a fresh one then erupts alongside it, producing in time a chain of progressively older volcanic islands in the middle of the ocean. During the Age of Man, a hot spot was responsible for producing the Hawaiian island chain, and in the Pacific at the present time a hot spot is in the process of generating the Batavian Islands. Birds are usually the first vertebrates to reach and settle on new islands, but in the case of Batavia the first vertebrates to arrive were their mammalian equivalent, the bats. By the time that the birds did arrive, the bats were so well established that there were few occupied evolutionary niches left, and the birds have never colonized the islands to any extent. The presence of suitable food on the ground, and the absence of predators enabled many bats to take up a terrestrial existence and to fill a large number of ecological niches. The flower has remained an insect eater, but it now largely sedentary. Its brightly colored ears and nose flaps mimic a species of flower found on the islands. It sits among them with its face turned upwards, snapping at any insect that attempts to land. It has glands around its mouth that produce a sweet-smelling secretion that is attractive to insects. The flightless shallot is an omnivorous tree-dwelling bat which spends its life hanging upside down like the ancient sloth. It eats leaves and occasional insect or small vertebrate caught by a swift jab of its single claw. The beaches are home for the packs of surf bats, which fish in the shallow waters around the coral reefs. Their hind legs, wings and tail flaps have developed into swimming and steering organs, and their bodies have become sleek and streamlined. Their evolution from a fly-in, through a terrestrial form, into an aquatic creature is very similar to the evolutionary development of the penguin. The streamlined aquatic cerbot is descended from a conventional flying bat ancestor. Its flippers, formed from what were once wings, have become stubby and muscular. On land the surf bat leaps along its tail and forelimbs when resting. Its tail is curled under its body. The largest and most fearsome is the night stalker. 1.5 meters tall, it roams screeching and screaming through the Batavian forest in night in packs. They prey indiscriminately on mammals and reptiles, attacking them with their ferocious teeth and claws. Its powerful front legs are developed from the wings of its ancestors. Its back feet, which were originally used for grasping and clutching, now come over its shoulders and effectively form hands. The evolution and versatility of the Pikayan whistlers. Several thousand kilometers east of the Australian subcontinent lies the island chain of Pakis. It was formed during the last 40 million years by friction between the northward moving Australian tectonic plate and the westward moving Pacific plate. At the margin between the two plates, volcanic islands were thrown up which gradually acquired of coral round their shores. After the ash and lava slopes were covered with vegetation and an insect population had been established, the island began to be colonized by birds. The first birds to arrive were the golden whistlers, which were blown across the ocean from Australia. Originally a fairly unspecialized bird, it had, during the Age of Man, begun to show some differentiation, with distinct beak shapes developing on the islands around the Australian coast. However, it was only on the Pakis archipelago, where all the ecological niches were thrown open to them, that the whistlers really developed spectacularly, producing both insectivorous gnad seed-eating as well as predatory forms. The descendants of the particular group of golden whistlers that colonized Pakis Islands are now regarded as belonging to a single genus, Insularni. All the species within this genus are now highly specialized and quite different from one another excepting Insularny harti, which is similar in form to the original ancestral bird. Insect-eater Pacuan whistler has developed a strong, chisel-like with which it tears into the bark of trees to get at burrowing insects. Its feet are modified to allow it to cling to the vertical trunks, and the bird closely resembles the extinct woodpeckers of the northern continent, whose mode of life it closely follows in almost every respect. All Pacuan whistlers are preyed upon by their hawk-like relative, the hawk whistler, which shows the same adaptations that are found in birds of prey throughout the world, irrespective of their ancestry: a hooked beak, binocular vision through forward-facing eyes, and a high degree of maneuverability in pursuit. Apart from the hawk whistler, the only natural enemies faced by the Pacuan whistlers are the snakes, which have been rafted to Pacus from Australia or the other islands in that corner of the Pacific at one time or another. The Pacuan whistler's wariness of snakes is exploited by the terratail, a timid rodent and one of the few mammals living on the island chain. The markings on its tail mimic to a remarkable degree the markings on the head of the Pacus bird snake, one of the most active and vicious snake of the archipelago. When threatened by a bird, or indeed by any other creature, the terratail throws its tail into the typical snake threat posture and utters a realistic hiss. It makes its escape rapidly into the undergrowth while its enemy is still recovering from the shock.